All right, here we go. Pizza times are normally distributed. We're trying to see if pizza times are less than 30 minutes. We have 36 times. This is the average. So this is less than this, but maybe we just got lucky, right? So we have to kind of figure it out with the standard deviation. So my HO, think, show, and tell. So in this part, I'm going to write my hypotheses. So I got HO and HA. My H naught or HO, or my first hypothesis, my null hypothesis is going to be mu equals 30, right? And we want to see if it's less than 30, so we're going to hypothesize that mu is actually less than 30, right? 30 minutes. If you want to write minutes, you can. Okay, now let's go ahead and show. So I'll show you with the normal curve, and then over here, I'll do it with the calculator. I don't know why I did that, we don't really need it. So this number is always going to go in the middle, so 30 is going to go in the middle. And then from there, our standard deviation is going to be 3.5 divided by the square root of 36. And our alpha value is going to be 0.01. So anything, if I get a p-value, this is our alpha, 0.01. If I get a p-value of less than 0.01, I'm going to go ahead and reject. If I get a p-value greater than 0.01, I'm going to go ahead and fail to reject. So let's figure out our p-value for 28.5. So in order to do that, we do x minus mu divided by our standard deviation to find out our z-score. So we go z equals, we're going to get a -1 here, which makes sense because underneath the mean, 28.5 minus 30 divided by 3.5 over the square root of 36. So let's figure out what that z is equal to. Real quick, this is a one-tail test because it's strictly less than, right? So let's go, throw some parentheses here, 28.5 minus 30 divided by, put this whole thing in 3.5 divided by the square root of 36, which I guess is 6. Enter, so that's what we got for a z value, negative 2.5714. So this is our z value. Now from there, we need to find our p value. So we go normal CDF, just like we did. This is the same as we were doing in video 1. So we're going from here all the way to that z value. So we're going to go negative 100 to negative 2.5714. So second distribution, normal CDF, negative 100, negative 2.5714, 0 and 1. Let's go ahead and figure that out, 0.005. So I get p-value, 0.005. So if you notice, that's the show. Now we got to tell. We thought with our hypothesis, we're showing here with all of our work, and now let's go ahead and tell. So this value, our p-value, is less than our alpha value. So that means that we were, here's our p-value in here, less than the cutoff, right? After this cutoff, we say that this is so rare that this probably didn't happen, right? So therefore, we reject HO for HA and say delivery times are less than 30 minutes. And then you can kind of do one of those. Cool. So again, we just said, okay, how far away from 30 is 28.5, right? It's pretty far. It's less than, it'll happen less than 1% of the time. It'll happen 0.005% of the time. So we're going to go ahead and reject. Now, let's say you're clever. You just want to do this, all this work here with a couple clicks of the button. You just go stat, go over to test, we're going to do a z-test, we're going to use, so you can either use data that you type in or you can use statistics. So here our mu is going to be 30. Our standard deviation is going to be 3.5. Our x bar is going to be 28.5. We have 36 things. And then from here you can go less, not equal to, so that's your two tail, less than, which is what we want, or greater than. We're going to go less than. Right? And let's go ahead and calculate that. So there's my p-value right there. There's my z-value right there. It gives me everything I need to. We got the same z, we got the same p, and then because that p is so low, we're going to fail to reject. It's like Snoop Dogg once said, if the p-value is low, the HO has to go. What you guys think about that? Homeowners think the speed of their cars is more than 35 miles an hour. Out of 100 cars, the mean speed is 36 miles an hour with a 4 mile an hour standard deviation. So we're going to have an alpha level of 0.05. So let's go HO, the HO, and the HA. If the P is low, the HO has to go. I'll share that meme with you. It's good. So HO, we want mu to be equal to 35, and we actually think that mu is greater than 35. So again, this is going to be a one-tail test. So now let's show here. So again, the reason why I'm doing this, you have to know what goes in the center, and then if you want to, you can use the calculator to do all the calculations. So 35 will go in the center. Right. This will be, we got 36 miles an hour, so that's kind of what we're testing here. We can call that x bar. Our standard deviation is 4, but then we have to divide that by the square root of 100, and we want our alpha level of 0.05. So here's my fence post, 0.05. Okay, so let's go ahead and let's find our z. So our z is going to equal, let's see here, 36 minus 35 divided by 4 over the square root of 100. So 36 minus 35 is going to be 1 divided by 4 over 10. Square root of 100 is 10. So it's going to give me 2.5. So that's my z. So now I go normal CDF. And I type in 2.5. I'm going greater than, so I'm going comma 100. See what I need to get that for my p-value. Let's go ahead and figure out what that is. Normal CDF, make it 2.5 all the way up to 100. Let's go ahead and see what that is, 0.006. So again, this is my p-value, 0.006, so that's like over here somewhere. Right, so that's far greater, far away than my 0.05. So again, we're going to reject again. So we're going to say our p-value is less than our alpha. Therefore, we reject HO. And say reject HO for HA. And say our speed is actually more than 35 miles per hour. Let's do that with the calculator real quick. Go stat, test, z-test, because we got a lot of data here, more than 20. Our mu we think is 35. Our standard deviation is 4. Our x bar is bigger, 36, and our n is big, and we're actually going greater than this time because we want to go the other way. We'll go ahead and calculate that. There you go. Got the same p, got the same z, right? So it's 2.5 standard deviations from the mean. The probability of that happening is about 0.6%, which is very small. If the HO is low, if the p is low, the null hypothesis has to go. All right, good stuff. Peace.